solving linear simultaneous equations where both equations need to be multiplied with adamonlinetutoring. Here's the beginner question, which will give some access to some of the harder questions you're likely to see in an exam. As spoken about in previous videos on solving simultaneous equations with no multiplying and multiplying one of the equations, the way you solve these is by making sure that the coefficient, the number in front of these terms here that you can see, is the same. On the previous video, we were able to multiply one of these equations to make it the same as the other. You're not going to be able to multiply 2 or 3 to get to the other one by using a whole number. This would make the question very difficult to do. So instead of multiplying one of them, we multiply both of them and find a lowest common multiple between the two numbers. For example, 2y and 3y can be made into 6y quite easily. We can multiply the first equation by 3. 4x times 3 is 12x. 2y times 3 is 6y. And 24 times 3 is 72. Next, we can multiply the second equation by 2. 3x times 2 is 6x. 3y times 2 is 6y. And 9 times 2 is 18. Once you have the coefficients the same, which is what we've got here, we look at the signs that are in front of those terms and decide whether we're using same sign subtract or different signs add. In this case, the signs are different, so we'll be adding the equations together to eliminate these two terms. 12x plus 6x is 18x. We don't need to worry about adding these two terms together. The whole reason we decide whether we're doing same sign subtract or different signs add is so that these terms cancel or eliminate, so we'll be left with nothing. 18x will be equal to 72 plus 18, which is 90. Now that we know 18x is 90, we can divide by 18 on both sides, so x would be equal to 5. We can substitute this back into one of the original equations to work out y. If you've watched my previous videos on this topic, you'll know that I prefer to substitute into the equation which has a positive in front of the variable that we're trying to find, like this one here. Substituting into the first equation then, we have 4 lots of x, and we now know that x is 5, so 4 lots of 5 is 20, plus 2y is equal to 24. And now we can solve this by subtracting 20 on both sides. 2y is equal to 4, and then divide by 2, so y must be equal to 2. So the final solutions to this question, x equals 5 and y equals 2. Slight increase in difficulty with the intermediate question, but definitely more similar to the types of questions that you're likely to see in an exam. The lowest common multiple of 5 and 3 is 15, so we can get to 15y by multiplying the top equation by 3 and the bottom equation by 5. Timesing the top one through by 3 gives us 9x plus 15y plus 21, and multiplying the second equation through by 5 is 20x plus 15y equals 10. Now that the coefficients are the same, look at the signs in front of them. These signs are the same, so we'll use same sign subtract. There's no obvious equation here to start with, and this catches quite a few people out in exams. Notice how we have a larger amount of x in the second equation, so it might make sense to do 20x take away 9x, but later on we have 21 at the top, which is larger than 10. The mistake that most people make is they'll start by doing 20x and they'll subtract 9x, which gives 11x, and then they'll switch and do 21 take away 10 instead. You're not allowed to swap halfway through. You need to stay consistent throughout. So we'll need to do 10 minus 21, which is negative 11. 11x is equal to negative 11. X would be equal to negative 1. We now know that x is negative 1, so let's substitute this back into one of the original equations. Both of them have a positive in front of the y terms, so it doesn't really matter which one we do. I'm just going to go with the second one. 4 lots of x, 4 lots of negative 1 is negative 4, plus 3y equals 2. We can solve this by adding 4 to both sides, so 3y would be equal to 6, and then dividing by 3 on both sides, so y is equal to 2. The solution to this question would be x equals negative 1 and y equals 2. Lastly, we have the advanced questions this time, which involves some problem-solving elements to them. In the first question, it looks like we need to do some rearranging to make it in the same format as the previous questions. Notice how we have 3y on the left-hand side of the equal sign, 4x on the right-hand side. Before, we had both of the algebraic parts on the left and the numerical part on the right. So let's just change this round. we can do that by subtracting 3y from both sides. That would leave us with 11 on the left hand side is equal to 4x minus 3y on the right hand side. So I'm going to rewrite the first equation as 4x minus 3y is equal to 11. I've just swapped the left hand side and the right hand side round. Makes no difference, they're both equal to each other. Secondly, I can rearrange this one quite easily to have algebraic parts on the left and numerical parts on the right by subtracting 1 from both sides. That would give me 10x plus 2y is equal to -1. Now we have them written in the same format as previously, I can just go ahead and do what we did before. The lowest common multiple of 3 and 2 is 6, so multiplying this one by 2 and this one by 3. 8x minus 6y is equal to 22, and 30x plus 6y is equal to -3. This time the signs are different, so we're going to use different signs add. 8x plus 30x is 38x. 22 add -3 is 19. This is another thing to watch out for. We have 38x is equal to 19. We're not going to do 38 divided by 19 is 2. It needs to be the other way around. 19 divided by 38, which means that x is actually a half, or 0.5. Now we know x is a half, we can substitute it back into any of the equations that we've got here, the one that we started with originally or the ones that we've created. I'm just going to go with the 10x plus 2y equals -1, just because it's the same format as the others that we've looked at. 10x and x is a half, so 10 halves or half of 10 is 5, plus 2y is equal to -1. Subtract 5 from both sides, 2y is equal to -6, and divide by 2 on both sides, so we're left with y is equal to -3. So the final solution, when x is a half, y is -3. For the last question, this doesn't appear very different in terms of the layout or the format of the question, but notice how we have a fraction of 2/3 here. Not a very common fraction to have on a non-calculator paper, which is what makes this one more difficult. The lowest common multiple of 3 and 4 is 12, so I can multiply the top one by 4 and the bottom one by 3 to make 12y in both. 8x plus 12y, and then we're multiplying 2/3 by 4, which is the same as 8/3. The bottom equation would be 9x minus 12y, and 18 times 3 is 54. Looking at the signs in front of the terms, we've made the same. These signs are different, so again, different signs add. 8x plus 9x is 17x, and this is the tricky bit without a calculator. To add fractions, it will be helpful to have them written with the same denominator. So 54 as a fraction over 3, we can just times the numerator by 3, is 162 over 3. That will make it easier to add these parts together. 8 over 3 plus 162 over 3 would be 170 over 3. If 17x is 170 over 3, dividing both sides by 17 would leave us with 10 over 3. Now we know that x is 10 over 3. I'm going to substitute this into the original first equation, where we have this positive in front of the term. 2 lots of x, 2 lots of 10 over 3 is 20 over 3, plus 3y is equal to 2 over 3. Subtract 20 over 3 from both sides, so 3y would be equal to -18 over 3. And finally, we can divide by 3, so y should be equal to -6 over 3, which is the same as -2. We could have written x as 3 and 1/3 if we wanted to, but you won't lose marks for this. So the final answers are x equals 3 and 1/3, or 10 over 3, and y equals -2. Before you go, take a little look at this solution that I've created for a question similar to one of the intermediate ones. I may have made a few mistakes. Let's see if you can pause the video, identify them, and write down what they are or some corrections in the comments below. Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with maths or finding topics difficult, you can subscribe and turn on notifications to receive regular updates about new video tutorials. Don't forget to visit my website adamonlinetutoring for a full searchable list of all topics with exams, questions and solutions. You can also visit me on social media using the handle @AdamMathsTutor on Instagram, TikTok, Facebook and Twitter. All links in the description below.